In question generation, our program parses a Wikipedia article and attempts to generate a given number of coherent grammatical questions. After receiving the Wikipedia article, we use Beautiful Soup to extract the relevant text from the article HTML. We then split our article into sentences, which the rest of our pipeline operates on. Generating questions from a sentence is very computationally expensive, so before we start, we filter sentences, selecting only those which we think are likely to generate good questions. In our filtering, we consider several things. We immediately discard sentences which are longer than 25 words, since they are expensive to parse and tend to generate poor, lengthy questions. We then require that all sentences contain at least one of several linking verbs, is, are, has been, have been, which we use to generate questions. After these two filters, we rank the remaining sentences based on the number of nouns, pronouns, and named entities they contain. Nouns and named entities are weighted positively, while pronouns are weighted negatively. Now that we have candidate sentences, we are ready to begin generating questions. In order to better understand the syntax of our sentences, we parse them with the Stanford parser. We then use Stanford TRegX to search for specific patterns in the resulting parse tree, which correspond to phrases where a subject and object are related by a linking verb. These tuples of subject, verb, object are the input to our next phase, question formation. Since calls to the Stanford parser are slow, we parallelize them using the Python multiprocessing library. We now feed these tuples of subject, verb, object to our question generation module. We use named entity recognition to search for named entities in the subject. If we find any, we can replace the subject with the WH word based on the class of the first named entity. If we had Obama is the President of the United States, we could recognize that Obama is a person and ask, who is the President of the United States? However, sometimes supersense tagging allows us to do even better. We supersense tag the named entities in an attempt to ask more specific questions. If we find that the first named entity in the subject is a child in WordNet of a known class, like cities or languages, we can augment our WH word with the name of this class. In the sentence, Pittsburgh is the city of bridges, we could recognize that Pittsburgh is a city and ask, which city is the city of bridges? Which sounds much more natural than, what is the city of bridges? Originally, we did this with any class returned by supersense, but this caused strange behavior on some sentences. For example, in happiness is a hot shower, we might have asked, what concept is a hot shower? In cases where named entity recognition and supersense tagging do not return useful results, we fall back to other strategies. If the subject of our phrase consists entirely of a pronoun or determiner, we replace the subject with the WH word related to that pronoun or determiner. For example, if we have the sentence, he is the President of the United States, we can infer that the pronoun has been resolved earlier in the article, replace the subject with the WH word who, and ask, who is the President of the United States? Finally, for other sentences where we cannot determine any useful information about the subject, we form a question by moving the verb to the front and asking a true-false question. For the sentence, the house was warm, we would ask, was the house warm? Sometimes we insert a negation before the object and ask, was the house not warm? Once we have generated all the questions that we can on an article, we transform each question into a feature vector with features like question type, length, number of named entities, number of nouns, and number of pronouns. We then use lasso regression, which we trained by hand ranking output from our program, to rank these feature vectors. Finally, we output the requested number of highest ranked questions. In question answering, we receive a Wikipedia article and a question, and need to answer the question based on the given article. As in question generation, we begin by processing the Wikipedia article with Beautiful Soup and splitting it into sentences. Our answering process is based on TF-IDF, but before that, we need to do some pre-processing. First, we stem every word in the article and in the question, the snowball stemmer. This reduces the number of words and causes different tenses or forms of words to collide. For example, walked and walking will become the same word, as will quickly and quick. We then build binary feature vectors for each sentence by checking to see which words in the sentence match words in the question. We found that using term presence instead of term frequency yields better results. When using term frequency, even with a logarithmic transform, we notice that longer sentences with many occurrences of a single word are often selected over shorter sentences with several words in the question. For example, if asked the question, does English influence the vocabulary of other languages? We might answer, see also English language in England, Northern England English, Scots language, Scottish English, Welsh English, Estuary English, Ulster English, and Hiberno English, rather than English has a strong influence on the vocabulary of other languages. Once we have the feature vectors for each sentence, we run TF-IDF and select the sentence with the highest rating. Now that we have our answer sentence, we attempt to improve it with coreference resolution. We provide our answer sentence, along with 6 sentences of context, to the BART coreference resolution system, and then rebuild the sentence, replacing pronouns with their resolutions. If our text said, Barack Obama was born in Honolulu, Hawaii. He is the President of the United States. And our answer sentence was, he is the President of the United States. We could resolve he to Barack Obama and give the answer sentence, Barack Obama is the President of the United States. We are Team Alpha Mafia. Thanks for watching.